clear thinking depends on the models in your mind. Richard Feynman built his thinking around simple models that explain how things work. You may have many facts, but facts alone do not guide you. A mental model is what connects facts. It tells you what matters and what does not. It shows what causes what and helps you stay steady when a topic becomes complex. Feynman explained that good thinking is not about sounding smart. It is about making sense. He reduced ideas to basic parts and clear links, and that is how he kept his thinking clean. Cognitive schema theory supports this. The brain stores knowledge in structures, and when the structure is weak, thinking becomes weak. Mental models shape how you think every day. A mental model is a simple explanation you carry in your head. You use it when you predict what will happen next, when you plan, when you choose, and when you judge. Even when you do not notice it, you are using some model. Feynman explained that a model is not a list of facts. It is a working map. It shows cause and effect. It shows how parts connect. It gives you a way to check whether an idea makes sense. When your model is clear, your choices become clearer. You can test your thinking and change your mind for a real reason. When your model is vague, you guess more. You follow slogans and react to surface details. Cognitive science supports this. People understand better when they build clear internal maps, not when they collect more words. A clear model makes thinking stable and useful. Feynman focused on process, not labels. You can name something and still not understand it. You can repeat a rule and still not know when it applies. He avoided this trap by asking how things actually work. He looked for what a system does, what makes it change, and what it produces. He explained ideas close to the mechanism. He did not hide behind terms or accept a definition as the final step. He wanted a model that could run in his mind like a simple machine. You begin to see the difference between knowing a word and knowing a system. A word can be memorized in seconds. A system must be understood step by step. Many things behave as linked parts, and when you understand the links, you understand the whole better. Understanding grows when you focus on how things work. Memorization can store facts, but it cannot guide thinking well. You may remember a formula or a rule, but when a new situation appears, your memory fails. Memorized facts often have no structure. They sit alone and do not explain why they matter. Feynman explained that a model travels better than a fact. A good model helps you handle new cases. It lets you adjust, reason from basics, and notice when something does not fit. You see this in daily life. If you memorize tips, you need a new tip for every problem. If you build a model, you can solve many problems with the same core idea. Learning research supports this. People transfer knowledge to new situations when they understand structure, not when they memorize steps. Models stay useful under pressure and change. They last longer than facts. Model building starts by splitting a big idea into smaller parts. When a topic feels complex, the mind tries to hold everything at once, which creates noise. Feynman avoided this by reducing problems. He asked what the parts are, what each part does, and how they link together. A big system is hard to check. A small part is easier to test and explain. When one part is clear, it can be trusted. When many parts are unclear, the whole becomes guesswork. Scientific problem solving supports this approach. It is not about ignoring the whole, but about controlling the details so the whole becomes understandable. You also remove noise by ignoring details that do not change the result and focusing on what drives the outcome. Simple parts create strong models. A model becomes real when it shows cause and effect. Many people stop at labels. They say something works because it works, or it happened because it happened. That is not a model. It stops thinking. Feynman explained that you must trace the chain. If one thing changes, what changes next? If something is removed, what fails? If the outcome shifts, which part caused it? This sharpens your thinking. You stop accepting vague reasons and start asking for real connections. Even a simple cause and effect link is better than a fancy word with no meaning. Research on causal reasoning shows that people understand systems better when they can explain why results happen, not just what happened. Clear links improve prediction and learning. Clean links create useful models. A model is not useful if it cannot be checked. You can build a neat explanation in your head and still be wrong. The mind creates stories that feel clear. Feynman did not trust that feeling. He trusted tests. He treated nature as the judge. If a model predicted one result and reality gave another, the model had to change. He did not defend it with excuses or hide behind authority. He updated it. This becomes a calm habit. You make a small prediction, check what happens, compare the result to the model, and fix the model. A useful model risks being wrong. If nothing could disprove it, it cannot guide action or learning. Wrong results are information. A real model must match real results. A model weakens when it hides behind complex words. You may hear a term and feel like the problem is solved. You may use a label and stop thinking. Feynman warned against this. Knowing the name is not knowing the thing. He used simple language because it forced honesty. If you cannot say it plainly, you may not understand it. Simple words also make models easier to test. You can check each part, explain it to others, and spot gaps faster. Jargon often blurs cause and effect by compressing many steps into one word. That can save time, but it can also hide weak links. Research shows that labels can create false confidence. The mind thinks it understands because it has the word. Simple words protect clear models. One of the fastest ways to build a model is to teach it to yourself. Feynman used explanation as a tool. He tried to explain ideas in plain words, and when he could not, he fixed the weak part. You can do this with a blank page. Write the topic down and explain it in short sentences. Avoid special terms unless you define them. Show the cause and effect chain and add a simple example. You will see where the model breaks. You may find a missing step or a vague reason, or notice that you are using a word instead of an explanation. That gap is the point. Research on active recall supports this. Rebuilding ideas from memory strengthens learning more than rereading. Teaching yourself forces meaning, not recognition. Explanation exposes weak models fast. A calm mind runs on a small set of strong models. Many people collect opinions and have views on everything, but opinions rarely explain or predict. They add noise. Feynman relied on fewer, stronger models that worked across many problems. He looked for basic structures that repeat in different forms. This reduces confusion because you are not switching frameworks all the time. In daily decisions, this helps you pause. Instead of reacting to every claim, you ask which model applies. You check causes, evidence, and limits, then decide. The brain has limited mental space. Too many loose ideas overload it. Strong models compress knowledge in a useful way and reduce guessing. This approach is not about having fewer thoughts, but about better structure. Strong models reduce mental noise. Mental models improve through daily practice, not one big lesson. Feynman treated thinking like a craft. He kept sharpening it. You can do the same with small, repeatable actions. Pick one idea, define it in plain words, break it into parts, link causes to effects, test a prediction and update the model. Over time, the mind becomes less reactive. You waste less time on weak ideas. You notice confusion earlier and correct faster. The brain changes with repeated use. Skills become smoother when practiced consistently. Small actions repeated daily build strong patterns. Feynman relied on method, not motivation. He used checks and clarity as a daily standard. Mental models grow stronger through daily practice.